Deep in the vast expanse of the universe, there lies a galaxy so massive, so mysterious, that it defies everything we thought we knew about the cosmos. This is NGC 4889, a colossal giant hidden within the Coma Cluster, and it holds secrets that could rewrite the story of our universe. Imagine a place where stars are born and die in the shadow of a supermassive black hole so enormous it could swallow our entire solar system without a second thought. A place where ancient red giants glow faintly, whispering tales of a time long before our sun even existed. This is not just any galaxy, it's a cosmic treasure chest filled with 30 of the strangest, most enigmatic objects ever discovered. From ghostly dark matter halos to hypervelocity stars racing through the void, NGC 4889 is a realm of endless wonder and mystery. But what makes this galaxy so unique? Why does it captivate astronomers and stargazers alike? And what secrets are still hidden within its swirling depths? Stay with us as we embark on an extraordinary journey to uncover the 30 strangest objects in NGC 4889, a galaxy that challenges our understanding of the universe and leaves us questioning everything we thought we knew. By the end of this video, you'll not only have explored the wonders of this cosmic giant, but also gained a deeper appreciation for the mysteries that lie beyond our own galaxy. So, are you ready to dive into the unknown? Let's begin. Now, let's turn our attention to the very heart of NGC 4889, where one of the most awe-inspiring objects in the universe resides: the supermassive black hole. This isn't just any black hole, it's a cosmic titan, one of the largest ever discovered. To put its size into perspective, this black hole has a mass estimated to be around 21 billion times that of our Sun. Imagine something so massive that it could easily swallow our entire solar system without breaking a sweat. But its size isn't the only thing that makes it extraordinary. The gravitational pull of this black hole is so immense that it shapes the very fabric of the galaxy around it. Stars, gas, and even light are drawn into its orbit, creating a swirling dance of matter and energy that defines the core of NGC 4889. This gravitational influence doesn't just affect its immediate surroundings, it plays a crucial role in the galaxy's overall structure, influencing how stars form and how the galaxy evolves over time. Without this supermassive black hole, NGC 4889, as we know it, simply wouldn't exist. It's a reminder of how even the most destructive forces in the universe can also be the architects of creation, shaping the cosmos in ways we're only beginning to understand. So, as we move deeper into the mysteries of NGC 4889, keep this colossal black hole in mind. It's the silent, invisible force that holds the galaxy together, and its story is just the beginning of the wonders we're about to uncover. Now, shifting our gaze slightly outward from the supermassive black hole, we encounter another marvel of NGC 4889, the enigmatic star clusters that orbit its core. These clusters are unlike anything you'd find in most galaxies. Picture a glittering swarm of stars packed so densely that they almost seem to touch one another. But how did these clusters come to be? The answer lies in the intense gravitational forces at play. As the supermassive black hole pulls in matter, it also compresses gas and dust, creating the perfect conditions for stars to form in rapid succession. Over time, these stars gather into clusters bound together by their mutual gravity. What's fascinating is the composition of these clusters. They're made up of some of the oldest stars in the galaxy, rich in heavy elements forged in the hearts of earlier generations of stars. This gives them a unique glow, a kind of cosmic fingerprint that tells the story of their origins. But why are they so tightly packed compared to star clusters in other galaxies? The answer lies in the extreme environment of NGC 4889. The gravitational pull of the supermassive black hole not only shapes the galaxy but also compresses these clusters, forcing stars into closer proximity than they would be elsewhere. This density creates a stunning visual spectacle, but it also has profound implications for the stars themselves. In such close quarters, stars can collide, merge, or even be flung out of the cluster entirely, adding another layer of complexity to the life cycle of these cosmic communities. As we continue to explore NGC 4889, these star clusters serve as a reminder of the intricate interplay between gravity, time, and the birth of stars, a dance that continues to shape the galaxy in ways we're only beginning to understand. Now, as we peel back another layer of NGC 4889 mysteries, we encounter something that's both invisible and utterly essential: the ghostly dark matter halo. Unlike the dazzling star clusters or the supermassive black hole, dark matter doesn't emit light or interact with electromagnetic forces, making it impossible to see directly. Yet, its presence is undeniable. This invisible halo envelops the entire galaxy, stretching far beyond its visible stars and gas. Think of it as the cosmic glue that holds NGC 4889 together. Without it, the galaxy would simply fly apart, its stars and planets scattering into the void. But how do we know it's there if we can't see it? Scientists rely on its gravitational effects. By observing how stars and gas move within the galaxy, they've noticed something peculiar: the outer regions of NGC 4889 rotate faster than they should if only visible matter were present. This discrepancy points to the existence of dark matter, whose gravitational pull keeps everything in check. Another clue comes from gravitational lensing, where the immense gravity of the dark matter halo bends light from distant objects behind it, creating distorted or magnified images. These observations allow astronomers to map the distribution of dark matter, revealing its vast, ghostly structure. What's truly fascinating is that dark matter makes up about 85% of the galaxy's total mass, dwarfing the contribution of ordinary matter. It's a humbling reminder that much of the universe remains hidden from our eyes, yet it plays a critical role in shaping the cosmos. As we continue to explore NGC 4889, the dark matter halo stands as a testament to the unseen forces that govern the universe, challenging us to look beyond what's visible and uncover the deeper truths of our cosmic home. Now, shifting our gaze to the ancient red giants of NGC 4889, we find ourselves staring at some of the oldest stars in the universe. These colossal stars, glowing with a deep reddish hue, are like the wise elders of the galaxy, having witnessed billions of years of cosmic history. Red giants are stars in the final stages of their life cycle, having exhausted the hydrogen fuel in their cores. As a result, they expand dramatically, swelling to hundreds of times their original size. This expansion cools their outer layers, giving them their characteristic red color. But why do these ancient stars appear so prominently in NGC 4889? The answer lies in the galaxy's age. NGC 4889 is an elliptical galaxy, a type of galaxy known for hosting some of the oldest stellar populations in the universe. Over time, many of its stars have evolved into red giants, creating a striking visual contrast against the younger, hotter stars. These red giants are also rich in heavy elements, forged in their cores and scattered into space when they eventually shed their outer layers. This process enriches the galaxy with the building blocks for new stars and planets, making red giants not just relics of the past but also contributors to the future. Their prominence in NGC 4889 serves as a reminder of the galaxy's long and dynamic history, offering us a glimpse into the life cycles of stars and the ever-changing nature of the cosmos. As we continue our journey through this extraordinary galaxy, the red giants stand as luminous markers of time, bridging the gap between the ancient and the new. Now, as we venture further into the depths of NGC 4889, we encounter a cosmic enigma that defies the natural order of stellar evolution, the mysterious blue stragglers. These peculiar stars stand out like youthful rebels in a crowd of aging giants, glowing with an intense blue light that suggests they are far younger than their surroundings. But here's the twist: they shouldn't exist. In a galaxy dominated by ancient stars, how do these seemingly youthful outliers come to be? The answer lies in two fascinating theories that challenge our understanding of stellar life cycles. The first theory suggests that blue stragglers are the result of stellar collisions. Imagine two older stars, each nearing the end of their lives, crashing into one another in a cosmic dance. The collision reignites their cores, merging their material into a single, rejuvenated star that burns hotter and brighter, appearing younger than it truly is. The second theory points to binary star systems, where two stars orbit each other closely. Over time, one star may siphon material from its companion, gaining mass and reigniting its nuclear furnace. This process can transform an aging star into a blue straggler, shining with newfound vigor. These stars are not just anomalies, they are windows into the dynamic and sometimes violent processes that shape galaxies. Their presence in NGC 4889 adds another layer of intrigue to this already fascinating galaxy, reminding us that even in the vastness of space, the unexpected is always waiting to be discovered. As we continue our exploration, the blue stragglers serve as a testament to the ever-changing and unpredictable nature of the cosmos. Moving deeper into the mysteries of NGC 4889, we now turn our attention to the cosmic dust clouds that shroud parts of this colossal galaxy. These vast, swirling clouds are more than just celestial veils. They are the birthplaces of stars, the cosmic nurseries where the building blocks of the universe come together. Composed primarily of tiny particles of carbon, silicon, and ice, these dust clouds are scattered throughout the galaxy, often obscuring our view of the stars and structures behind them. But their role goes far beyond mere obstruction. These clouds are the raw materials for star formation, acting as the cosmic factories where gas and dust collapse under gravity, igniting the fires of new stars. The process begins when regions within these clouds become dense enough to trigger gravitational collapse. As the material condenses, it heats up, eventually reaching temperatures high enough to spark nuclear fusion. This marks the birth of a new star, a process that can take millions of years but is essential to the life cycle of galaxies. The dust clouds also play a crucial role in shaping the galaxy's structure. As stars form within them, their radiation and stellar winds push the surrounding dust and gas, carving out cavities and influencing the distribution of matter across NGC 4889. Interestingly, these clouds are not uniform. Some are thick and opaque, while others are thinner and more diffuse, allowing light to pass through. This variation creates a patchwork of light and shadow, adding to the galaxy's visual complexity. Scientists study these clouds to understand not only how stars form, but also how galaxies evolve over time. By analyzing the composition and behavior of these dust clouds, we gain insights into the processes that drive the growth and transformation of galaxies like NGC 4889. As we continue our journey through this extraordinary galaxy, the cosmic dust clouds remind us of the delicate balance between creation and obscurity, between the visible and the hidden. They are a testament to the ongoing cycle of birth and renewal that defines the universe, offering a glimpse into the forces that shape the cosmos. Next, we'll explore another fascinating feature of NGC 4889, the peculiar radio jets that emanate from its core, revealing even more about the dynamic nature of this galactic giant. Now, let's shift our gaze to one of the most dramatic features of NGC 4889, the peculiar radio jets that burst forth from its core. These jets are not just ordinary streams of energy. They are colossal beams of radio waves stretching far beyond the galaxy itself, and they hold the key to understanding some of the most energetic processes in the universe. These radio jets originate from the supermassive black hole at the heart of NGC 4889. As matter spirals into the black hole, it doesn't all disappear into oblivion. Instead, some of it gets funneled into powerful jets that shoot out from the black hole's poles at nearly the speed of light. These jets are made up of charged particles and magnetic fields, creating a kind of cosmic particle accelerator that can stretch for hundreds of thousands of light years. The energy source behind these jets is nothing short of astonishing. As the black hole devours surrounding gas and dust, it releases immense amounts of energy, some of which gets channeled into these jets. This process is so powerful that it can outshine the entire galaxy, making the jets visible across vast cosmic distances. But what makes these jets truly fascinating is how they interact with the surrounding space. As they travel outward, they collide with the intergalactic medium, the thin gas that fills the space between galaxies. These collisions create shock waves, heating the gas and sometimes even triggering the formation of new stars. The jets also carry magnetic fields with them, which can influence the structure of the galaxy and its surroundings over time. Interestingly, the radio jets are not constant. They can vary in intensity, sometimes flaring up and other times fading away. This variability gives scientists clues about the activity of the black hole and the conditions in the galaxy's core. By studying these jets, astronomers can learn more about the behavior of supermassive black holes and their role in shaping galaxies like NGC 4889. As we marvel at these cosmic fountains of energy, we're reminded of the incredible forces at work in the universe. The radio jets of NGC 4889 are not just a spectacle, they are a window into the dynamic and ever-changing nature of galaxies. Next, we'll turn our attention to the glowing nebulae scattered throughout this galaxy, where the beauty of star birth unfolds in vibrant colors. Now, let's step into a world of vibrant cosmic artistry as we explore the glowing nebulae of NGC 4889. These vast clouds of gas and dust are not just beautiful to behold, they are the cradles of new stars, painting the galaxy with their luminous hues. Nebulae are often referred to as the nurseries of the universe, and for good reason. Within these glowing clouds, the raw materials for star formation are abundant. Hydrogen, helium, and traces of heavier elements like carbon and oxygen swirl together, creating the perfect environment for stars to be born. When pockets of gas within a nebula become dense enough, they collapse under their own gravity, igniting the process of nuclear fusion and giving birth to new stars. The nebulae in NGC 4889 are particularly striking because of their vivid colors. These colors come from the way the gas interacts with light. For example, hydrogen gas emits a characteristic red glow when energized by nearby stars, while oxygen can produce a bluish tint. These colors not only make the nebulae visually stunning, but also provide astronomers with valuable information about their composition and temperature. One of the most fascinating aspects of these nebulae is their role in the life cycle of stars. As stars form within them, they begin to shine, illuminating the surrounding gas and creating the glowing effect we see. Over time, these young stars can also influence their birthplaces, blowing away the remaining gas with their stellar winds, or even triggering the formation of more stars through shock waves. But nebulae are more than just star factories. They are also cosmic recycling centers. When massive stars reach the end of their lives and explode as supernova, they scatter their enriched material back into the surrounding nebulae. This material, now rich in heavier elements like iron and silicon, becomes part of the next generation of stars and planets. In this way, nebulae play a crucial role in the ongoing cycle of stellar evolution. As we marvel at the glowing nebulae of NGC 4889, we're reminded of the interconnectedness of the universe. These clouds of gas and dust are not just isolated features. They are part of a grand cosmic dance, shaping and reshaping the galaxy over billions of years. Next, we'll take a closer look at the warped spiral arms of NGC 4889, where the galaxy's structure tells a story of gravitational interactions and cosmic collisions. Now, shifting our gaze to the outer reaches of NGC 4889, we encounter one of its most intriguing features, the warped spiral arms. Unlike the symmetrical, sweeping arms seen in many spiral galaxies, the arms of NGC 4889 appear twisted and distorted, as if sculpted by an unseen cosmic hand. This peculiar structure tells a story of gravitational forces at play, shaping the galaxy in ways that defy the norm. The distortion in NGC 4889 spiral arms is likely the result of gravitational interactions with neighboring galaxies. Over billions of years, galaxies in close proximity can exert powerful tidal forces on one another, pulling and stretching their structures. These interactions can warp the delicate balance of a galaxy's spiral arms, bending them out of their natural shape. In the case of NGC 4889, it's possible that a past encounter with a smaller galaxy or even a near miss with a larger one has left its mark, creating the unusual patterns we observe today. But what makes these warped arms so fascinating is not just their appearance but what they reveal about the galaxy's history. The distortions act like cosmic fingerprints, preserving evidence of past events that would otherwise be lost to time. By studying the shape and movement of these arms, astronomers can piece together the timeline of NGC 4889 interactions, uncovering clues about the forces that have shaped its evolution. Another intriguing aspect of these warped arms is their impact on star formation. While the distortion might seem chaotic, it can actually trigger bursts of star formation in certain regions. As the arms are stretched and compressed by gravitational forces, pockets of gas and dust can become denser, creating the perfect conditions for new stars to ignite. This means that even in the midst of cosmic turmoil, life, in the form of stars, can flourish. As we reflect on the warped spiral arms of NGC 4889, we're reminded of the dynamic nature of the universe. Galaxies are not static entities, they are constantly evolving, shaped by the forces around them. The twisted arms of NGC 4889 serve as a testament to the power of gravity and the interconnectedness of all things in the cosmos. Next, we'll turn our attention to the hypervelocity stars of NGC 4889, where speed and mystery collide in the vast expanse of space. Now, let's zoom in on one of the most thrilling phenomena in NGC 4889, the hypervelocity stars. These are not your average stars, they are cosmic speedsters, racing through the galaxy at mind-boggling velocities. Imagine a star traveling so fast that it could cross the distance between Earth and the Moon in just a few minutes. That's the kind of speed we're talking about here. But how do these stars achieve such incredible velocities? The answer lies in the heart of NGC 4889, where its supermassive black hole plays the role of a cosmic slingshot. Hypervelocity stars are thought to be the result of close encounters with the supermassive black hole at the center of the galaxy. When a star ventures too close to the black hole, it can get caught in an intense gravitational dance. In some cases, the black hole's immense gravity can fling the star outward at astonishing speeds, sending it hurtling through the galaxy like a celestial bullet. This process, known as a gravitational slingshot, is one of the few mechanisms capable of accelerating stars to such extreme velocities. But the journey of a hypervelocity star doesn't end there. Once ejected, these stars continue their high-speed travels, often breaking free from the gravitational pull of NGC 4889 entirely. Some may even escape into intergalactic space, becoming rogue stars adrift in the vast emptiness between galaxies. This makes hypervelocity stars not only fascinating to study, but also valuable tools for understanding the dynamics of black holes and the forces that govern galactic evolution. What's particularly intriguing about these stars is the trail of clues they leave behind. By tracking their paths and measuring their speeds, astronomers can piece together the history of their interactions with the black hole. This information provides insights into the behavior of supermassive black holes and the extreme environments surrounding them. It's like reading a cosmic detective story where each hypervelocity star holds a piece of the puzzle. As we marvel at the hypervelocity stars of NGC 4889, we're reminded of the sheer power and unpredictability of the universe. These stars are a testament to the incredible forces at play in the cosmos, where even the most massive objects can be set into motion by the gravitational whims of a black hole. Next, we'll explore the remnants of ancient quasars in NGC 4889, uncovering the echoes of a time when the galaxy's core was a beacon of unimaginable energy. Now, let's turn our attention to the echoes of a bygone era in NGC 4889, the remnants of ancient quasars. These ghostly relics are like cosmic time capsules, offering us a glimpse into the galaxy's fiery past. Quasars, often referred to as the brightest objects in the universe, are powered by supermassive black holes feeding on vast amounts of gas and dust. But what happens when the fuel runs out and the quasar fades? That's where these remnants come into play. In NGC 4889, the quasar remnants tell a story of a time when the galaxy's core was a blazing powerhouse. Imagine a supermassive black hole surrounded by a swirling disk of material, glowing so intensely that it outshone the entire galaxy. Over millions of years, as the black hole consumed its surrounding material, the quasar's light dimmed, leaving behind faint traces of its former glory. These remnants, often detected as faint radio waves or X-ray emissions, are the last whispers of a once dominant force. Studying these remnants is like piecing together a cosmic puzzle. They provide crucial clues about how supermassive black holes evolve over time. For instance, the remnants can reveal how much material the black hole consumed during its active phase and how this process influenced the surrounding galaxy. This information helps astronomers understand the life cycle of supermassive black holes, from their fiery youth as quasars to their quieter, more subdued states in the present day. One of the most fascinating aspects of quasar remnants is their role in shaping the galaxy. During their active phase, quasars can unleash powerful jets of energy that push gas and dust out of the galaxy, effectively halting star formation in certain regions. This means that the remnants we see today are not just passive leftovers, they are markers of a transformative period in NGC 4889 history. By studying them, we can better understand how quasars influence the growth and structure of galaxies over billions of years. As we explore these ancient remnants, we're reminded of the dynamic and ever-changing nature of the universe. NGC 4889 quasar remnants are a testament to the galaxy's turbulent past, where immense forces shaped its destiny. Next, we'll delve into the evidence of galactic cannibalism in NGC 4889, uncovering how this colossal galaxy has grown by consuming its smaller neighbors. Now, let's shift our gaze to a phenomenon that reveals the darker side of galactic evolution: the evidence of galactic cannibalism in NGC 4889. This colossal galaxy hasn't grown to its immense size by chance. It has devoured smaller galaxies over billions of years, leaving behind telltale signs of its cosmic feasts. One of the most striking pieces of evidence lies in the streams of stars that stretch across the galaxy's outskirts. These streams are like cosmic breadcrumbs, tracing the paths of smaller galaxies that were torn apart by NGC 4889's immense gravitational pull. As these galaxies were drawn in, their stars were scattered, creating long, faint trails that wind through the galaxy's halo. These streams are not just remnants of destruction. they are a record of NGC 4889 growth, showing how it has expanded by consuming its neighbors. Another clue comes from the disrupted orbits of stars within the galaxy. In a typical galaxy, stars follow orderly, predictable paths around the galactic center. But in NGC 4889, some stars move in chaotic, irregular orbits, a sign that they were once part of smaller galaxies that were absorbed. These disrupted orbits are like fingerprints, revealing the violent mergers that have shaped NGC 4889 over time. Galactic cannibalism isn't just a dramatic event, it's a fundamental process in the life of a galaxy. When NGC 4889 consumes a smaller galaxy, it gains not only stars but also gas and dust, which can fuel new rounds of star formation. This means that the galaxy's growth isn't just about size, it's about transformation. Each merger leaves its mark, altering the galaxy's structure and composition in ways that can last for billions of years. As we piece together the evidence of galactic cannibalism, we gain a deeper understanding of how galaxies like NGC 4889 evolve. These cosmic mergers are a reminder that the universe is a dynamic, ever-changing place where even the largest structures are shaped by the forces of gravity and time. Next, we'll explore the unusual gamma-ray emissions detected from NGC 4889, uncovering what these high-energy signals might reveal about the galaxy's most extreme processes. Now, let's turn our attention to a phenomenon that lights up the galaxy in ways we can barely comprehend: the unusual gamma-ray emissions detected from NGC 4889. Gamma rays are the most energetic form of light in the universe, and their presence in this galaxy hints at some of the most extreme processes taking place within it. But what could be producing these high-energy signals? Let's dive into the possibilities. One of the leading explanations points to the supermassive black hole at the heart of NGC 4889. As matter spirals into the black hole, it heats up to incredible temperatures, releasing bursts of energy across the electromagnetic spectrum, including gamma rays. These emissions could be the result of jets of particles being ejected at nearly the speed of light, a phenomenon often seen in active galactic nuclei. These jets, powered by the black hole's immense gravitational energy, can stretch for thousands of light years, illuminating the surrounding space with gamma rays. Another potential source of these emissions could be cosmic collisions. When galaxies merge or massive stars explode, the resulting shock waves can accelerate particles to extreme speeds, producing gamma rays in the process. In a galaxy as dynamic as NGC 4889, where galactic cannibalism has been a recurring theme, such collisions are not uncommon. The remnants of these violent events could be contributing to the gamma-ray glow we observe. But there's more to this story. Gamma-ray emissions can also come from other exotic sources, such as pulsars or even dark matter interactions. Pulsars, the rapidly spinning cores of dead stars, emit beams of radiation that can include gamma rays. If NGC 4889 hosts a population of these cosmic lighthouses, they could be adding to the galaxy's gamma-ray signature. On the other hand, some theories suggest that dark matter particles, when they collide and annihilate, could produce gamma rays. While this remains speculative, it's a tantalizing possibility that adds another layer of mystery to NGC 4889. Understanding these gamma-ray emissions is crucial because they offer a window into the most energetic processes in the universe. By studying them, astronomers can learn more about the behavior of black holes, the aftermath of cosmic collisions, and even the nature of dark matter. Each burst of gamma rays is like a cosmic telegram, carrying information about the extreme environments that produced it. As we continue to unravel the secrets of NGC 4889, these gamma-ray emissions remind us that the galaxy is far from a quiet, static place. It's a dynamic, ever-changing arena where the most powerful forces in the universe are constantly at play. Next, we'll explore the massive star-forming regions in NGC 4889, where new stars are born at an astonishing rate, adding yet another layer of wonder to this cosmic giant. Now, shifting our gaze to the vibrant heart of NGC 4889, we encounter one of the most awe-inspiring sights in the cosmos, the massive star-forming regions. These are the cosmic nurseries where new stars are born, and in NGC 4889, this process happens at a pace that defies imagination. But what makes these regions so prolific, and how do they manage to churn out stars at such an astonishing rate? Let's take a closer look. The key to this stellar productivity lies in the unique conditions found within these regions. First, there's the abundance of raw materials. NGC 4889 is rich in gas and dust, the essential ingredients for star formation. These clouds of gas, primarily hydrogen, collapse under their own gravity, heating up until nuclear fusion ignites, giving birth to a new star. In NGC 4889, these clouds are not only vast but also incredibly dense, creating the perfect environment for stars to form in rapid succession. Another critical factor is the presence of shock waves. These can be triggered by supernova explosions or the gravitational interactions between galaxies. When a massive star reaches the end of its life and explodes, it sends shock waves rippling through the surrounding gas clouds. These shock waves compress the gas, triggering the collapse of new clouds and accelerating the star-forming process. In a galaxy as dynamic as NGC 4889, where galactic collisions and mergers are common, these shock waves are frequent and powerful, fueling the birth of countless stars. Temperature also plays a vital role. In the coldest regions of these gas clouds, molecules move more slowly, allowing gravity to pull them together more easily. However, star-forming regions in NGC 4889 are not just cold, they're also turbulent. This turbulence creates pockets of varying density, some of which become dense enough to collapse and form stars. The interplay between cold temperatures and turbulent motion creates a perfect storm for star formation. But perhaps the most fascinating aspect of these regions is their sheer scale. Some of the star-forming regions in NGC 4889 span hundreds of light years, containing enough material to form thousands, if not millions, of stars. Within these colossal nurseries, stars are born in clusters, often surrounded by their siblings. These clusters can range from a few dozen stars to massive groupings containing hundreds of thousands of stars, all born from the same cloud of gas and dust. The result is a galaxy teeming with young, hot stars, their light illuminating the surrounding gas and dust in brilliant hues of blue and white. These regions are not just beautiful, they're also crucial to the evolution of NGC 4889. The energy and radiation emitted by these young stars can shape the surrounding environment, triggering further star formation or dispersing gas clouds, depending on the circumstances. As we marvel at these star-forming regions, we're reminded of the incredible dynamism of NGC 4889. It's a galaxy where the cycle of birth, life, and death plays out on a grand scale, shaping its structure and future. Next, we'll delve into the elusive intermediate mass black holes that may lurk within this cosmic giant, adding yet another layer of intrigue to its already fascinating story. Now, as we venture deeper into the mysteries of NGC 4889, we turn our attention to a phenomenon that has long puzzled astronomers: the elusive intermediate mass black holes. These cosmic enigmas sit somewhere between the smaller stellar mass black holes and the supermassive giants that dominate galactic centers. But what exactly are they, and why are they so hard to find? Intermediate mass black holes are thought to weigh anywhere from a few hundred to a few 100,000 times the mass of our Sun. This places them in a unique category, bridging the gap between the black holes formed from collapsing stars and the supermassive ones like the one at the heart of NGC 4889. Their existence could hold the key to understanding how supermassive black holes grow to such enormous sizes. But detecting them is no easy task, as they don't emit the same intense radiation as their larger counterparts. One leading theory suggests that intermediate mass black holes could form through the collision and merging of smaller black holes. In a galaxy as dense and dynamic as NGC 4889, where stars and black holes are packed closely together, such collisions might occur more frequently. Over time, these mergers could create black holes of intermediate mass, acting as stepping stones on the path to supermassive status. Another possibility is that they form directly from the collapse of massive gas clouds. In the early universe, before galaxies like NGC 4889 took shape, enormous clouds of gas could have collapsed under their own gravity, bypassing the star formation stage entirely and giving birth to intermediate mass black holes. These primordial black holes might then have been incorporated into galaxies as they formed, lurking in the shadows ever since. The significance of these black holes goes beyond their formation. They could play a crucial role in the evolution of galaxies. For instance, they might act as seeds for supermassive black holes, growing over billions of years through accretion and mergers. They could also influence the motion of stars and gas in their vicinity, shaping the structure of the galaxy in subtle but important ways. Despite their potential importance, intermediate mass black holes remain incredibly difficult to detect. Unlike supermassive black holes, which are surrounded by bright accretion disks, or stellar mass black holes, which can be spotted through their interactions with companion stars, intermediate mass black holes often leave little trace. Astronomers rely on indirect evidence, such as the gravitational effects they have on nearby stars or the faint X-ray emissions they might produce. In NGC 4889, the search for these elusive objects continues. The galaxy's dense core and rich history of collisions make it a prime candidate for hosting intermediate mass black holes. If discovered, they could provide invaluable insights into the growth of supermassive black holes and the early stages of galaxy formation. As we ponder the mysteries of these hidden giants, we're reminded of how much there is still to learn about the cosmos. Next, we'll explore the cosmic web filaments that connect NGC 4889 to the wider universe, revealing the intricate network that binds galaxies together. Now, shifting our gaze to the grand tapestry of the universe, we encounter the cosmic web filaments, the vast, thread-like structures that weave galaxies like NGC 4889 into the larger cosmic fabric. These filaments are the highways of the cosmos, connecting galaxies and galaxy clusters across unimaginable distances. But what exactly are they, and how do they shape the universe as we know it? The cosmic web is made up of dark matter and gas, forming a network of filaments that stretch across the universe. These filaments act as the scaffolding upon which galaxies are built, guiding the flow of matter and energy. NGC 4889, like all galaxies, is not an isolated island in space but a part of this intricate network. The filaments surrounding it serve as conduits, channeling gas and other materials that fuel star formation and galactic growth. One of the most fascinating aspects of these filaments is their role in the large-scale structure of the universe. They form the backbone of what astronomers call the cosmic web, a term that captures the interconnected nature of everything in the cosmos. Without these filaments, galaxies would be scattered randomly, and the universe as we know it would look entirely different. Instead, they create a pattern of voids and dense regions, with galaxies clustering along the filaments like beads on a string. The formation of the cosmic web is a direct result of the universe's expansion and the gravitational pull of dark matter. In the early universe, tiny fluctuations in density grew over time, with dark matter clumping together to form the first filaments. Ordinary matter, like gas, followed suit, flowing into these dark matter structures and eventually collapsing to form galaxies. This process continues today, with filaments feeding galaxies like NGC 4889 with the raw materials needed for star formation and evolution. Studying these filaments is no easy task, as they are incredibly faint and spread across vast distances. Astronomers rely on advanced techniques, such as mapping the distribution of galaxies and observing the faint glow of gas within the filaments to piece together their structure. In the case of NGC 4889, its position within the cosmic web offers clues about its history and future. The filaments connecting it to other galaxies may have played a role in its growth, providing the gas and stars that have shaped it into the colossal galaxy we see today. The cosmic web also holds clues to some of the universe's biggest mysteries, such as the nature of dark matter and dark energy. By studying how filaments evolve and interact with galaxies, scientists hope to uncover the forces that drive the universe's expansion and shape its destiny. NGC 4889, with its connections to the cosmic web, is a vital piece of this cosmic puzzle. As we marvel at the intricate network that binds galaxies together, we're reminded of the profound interconnectedness of the universe. Next, we'll turn our attention to the rare hyperluminous X-ray sources in NGC 4889, mysterious objects that shine with an intensity that defies explanation. Now, let's zoom in on one of the most dazzling mysteries within NGC 4889, the rare hyperluminous X-ray sources. These cosmic powerhouses emit X-rays at levels so intense that they outshine entire galaxies. But what exactly are these enigmatic objects, and what could possibly fuel their extraordinary brightness? Hyperluminous X-ray sources, or HLX, are among the brightest X-ray emitters in the universe. Unlike the X-rays we're familiar with, which often come from black holes or neutron stars, these sources are on a whole different scale. Their luminosity can be thousands of times greater than that of typical X-ray sources, making them stand out even in a galaxy as massive as NGC 4889. But here's the twist: scientists are still unraveling what causes them to shine so brightly. One leading theory suggests that these sources could be intermediate mass black holes, larger than stellar black holes but smaller than the supermassive ones at the centers of galaxies. These intermediate black holes might be devouring matter at an incredible rate, releasing vast amounts of energy in the form of X-rays. Another possibility is that they're the result of stellar collisions or the remnants of smaller galaxies that NGC 4889 has absorbed over time. In either case, the sheer intensity of their X-ray emissions makes them a fascinating subject of study. What makes these hyperluminous sources even more intriguing is their rarity. They're not found in every galaxy, and their presence in NGC 4889 adds another layer of mystery to this already enigmatic galaxy. Astronomers use advanced telescopes like the Chandra X-ray Observatory to study these sources in detail. By analyzing their X-ray emissions, scientists hope to uncover clues about their origins and the processes that power them. The discovery of hyperluminous X-ray sources in NGC 4889 also raises questions about the galaxy's history. Could these sources be evidence of past galactic collisions or mergers, or do they point to unique conditions within NGC 4889 that allow such extreme phenomena to occur? As researchers continue to investigate, these sources remain a tantalizing puzzle, offering a glimpse into the dynamic and often violent processes that shape galaxies. As we marvel at the brilliance of these X-ray beacons, we're reminded of how much there is still to learn about the universe. Next, we'll explore the ancient globular clusters orbiting NGC 4889, dense collections of stars that hold secrets of the galaxy's earliest days. Now, shifting our gaze to the outskirts of NGC 4889, we encounter the ancient globular clusters, dense, spherical collections of stars that orbit the galaxy like cosmic time capsules. These clusters are among the oldest structures in the universe, with some dating back nearly as far as the Big Bang itself. But what makes them so special, and what can they tell us about the history of NGC 4889? Globular clusters are like stellar cities packed with hundreds of thousands or even millions of stars. Unlike the stars in the galaxy's spiral arms, which are relatively young and spread out, the stars in these clusters are tightly bound by gravity, forming a dense, shimmering sphere. Their age is staggering. Many of these clusters are over 10 billion years old, making them some of the first structures to form in the early universe. This makes them invaluable to astronomers as they provide a snapshot of the conditions and processes that shaped galaxies like NGC 4889. The composition of these clusters is equally fascinating. They are primarily made up of old, metal-poor stars, meaning they contain fewer heavy elements like iron and carbon compared to younger stars. This lack of heavy elements suggests that these stars formed before the universe had been enriched by multiple generations of stellar explosions. Studying these ancient stars helps scientists piece together the chemical evolution of the cosmos and understand how galaxies like NGC 4889 grew and changed over billions of years. But globular clusters aren't just relics of the past, they also hold clues about the galaxy's formation and evolution. Many of these clusters are thought to have formed alongside NGC 4889 itself, acting as building blocks in the galaxy's early days. Others may have been captured from smaller galaxies that NGC 4889 absorbed over time, a process known as galactic cannibalism. By mapping the positions and movements of these clusters, astronomers can trace the galaxy's history of mergers and interactions, revealing how it grew into the colossal structure we see today. One of the most intriguing aspects of globular clusters is their role in understanding dark matter. These clusters orbit the galaxy in predictable patterns, but their movements sometimes hint at the presence of unseen mass. By studying these orbits, scientists can infer the distribution of dark matter in and around NGC 4889, shedding light on one of the universe's greatest mysteries. As we marvel at these ancient stellar gatherings, we're reminded of the deep connections between the past and present. Next, we'll delve into the mysterious influence of dark energy on NGC 4889 and how it shapes the galaxy's future. Now, as we venture deeper into the mysteries of NGC 4889, we encounter one of the most enigmatic forces in the universe, dark energy. This invisible, pervasive energy is thought to be driving the accelerated expansion of the cosmos, and its influence extends even to galaxies as massive as NGC 4889. But what exactly is dark energy, and how does it shape the fate of this colossal galaxy? Dark energy is a mysterious force that makes up about 68% of the universe's total energy content. Unlike gravity, which pulls objects together, dark energy acts as a kind of cosmic repulsion, pushing galaxies apart and causing the universe to expand at an ever-increasing rate. For NGC 4889, this means that the space between it and other galaxies is stretching over time, creating vast cosmic voids. But studying this phenomenon is no easy task, as dark energy doesn't interact with light or matter in any way we can directly observe. One of the biggest challenges in understanding dark energy lies in its invisibility. Unlike stars, gas clouds, or even dark matter, dark energy leaves no trace that we can detect with telescopes or instruments. Instead, scientists rely on indirect methods to study its effects. For example, by observing distant supernovae, astronomers can measure how quickly the universe is expanding and infer the presence of dark energy. Similarly, the large-scale structure of the universe, how galaxies are distributed across space, offers clues about dark energy's influence. In the case of NGC 4889, researchers look at how its position and movement relative to other galaxies change over time, providing insights into the role dark energy plays in shaping its cosmic neighborhood. Another challenge is separating the effects of dark energy from those of gravity and dark matter. While dark energy pushes galaxies apart, gravity pulls them together, and dark matter provides the invisible scaffolding that holds galaxies in place. In a galaxy as massive as NGC 4889, these forces are constantly at odds, creating a complex interplay that's difficult to untangle. For instance, the galaxy's supermassive black hole and its surrounding dark matter halo exert a strong gravitational pull, which can mask or distort the subtle effects of dark energy. This makes it incredibly challenging to isolate and study dark energy's impact on NGC 4889 specifically. Despite these challenges, understanding dark energy is crucial to unraveling the ultimate fate of the universe. If dark energy continues to dominate, it could lead to a future where galaxies like NGC 4889 are so far apart that they become isolated islands in an ever-expanding void. Alternatively, if dark energy's influence changes over time, it could alter the trajectory of cosmic expansion in ways we can't yet predict. For now, NGC 4889 serves as a fascinating laboratory for studying this mysterious force, offering a glimpse into the forces that shape not just galaxies but the entire cosmos. As we ponder the profound implications of dark energy, our journey through NGC 4889 takes us to another intriguing phenomenon: the unusual magnetic fields that ripple through this galaxy, shaping its structure and influencing its evolution. Now, shifting our focus to another fascinating aspect of NGC 4889, we encounter the unusual magnetic fields that ripple through this colossal galaxy. These magnetic fields are not just subtle forces, they play a significant role in shaping the galaxy's structure and influencing its evolution. But what makes these magnetic fields so unique, and how do they impact the cosmic processes within NGC 4889? Magnetic fields in galaxies are often generated by the movement of charged particles, such as electrons and protons, within the interstellar medium. In NGC 4889, these fields are particularly strong and complex, stretching across vast regions of the galaxy. Unlike the more uniform magnetic fields found in some spiral galaxies, the fields in NGC 4889 appear twisted and irregular, creating a dynamic and ever-changing environment. This irregularity is thought to be influenced by the galaxy's turbulent history, including its interactions with neighboring galaxies and the immense gravitational forces exerted by its supermassive black hole. One of the most intriguing effects of these magnetic fields is their influence on star formation. In regions where the magnetic fields are strong, they can either promote or hinder the birth of new stars. On one hand, magnetic fields can compress gas clouds, triggering the collapse of these clouds into dense cores that eventually form stars. On the other hand, they can also prevent gas from collapsing by exerting pressure, effectively putting a brake on star formation. In NGC 4889, this delicate balance between magnetic forces and gravity creates a patchwork of star-forming regions, some bursting with activity while others remain eerily quiet. These magnetic fields also play a crucial role in shaping the galaxy's overall dynamics. For instance, they can channel and accelerate cosmic rays, high-energy particles that travel through space at nearly the speed of light. These cosmic rays, in turn, can heat the surrounding gas, preventing it from cooling and collapsing into stars. This process helps explain why some parts of NGC 4889 have fewer young stars compared to other galaxies. Additionally, the magnetic fields can influence the movement of gas and dust, redistributing these materials across the galaxy and affecting its long-term evolution. Studying these magnetic fields is no easy task as they are invisible to traditional telescopes. Instead, astronomers rely on indirect methods, such as observing the polarization of light emitted by stars and gas clouds. Polarization occurs when light waves vibrate in a specific direction, and this can reveal the orientation and strength of magnetic fields. By analyzing these patterns, scientists can piece together a map of the magnetic fields in NGC 4889, shedding light on their structure and impact. As we continue to unravel the mysteries of NGC 4889, these unusual magnetic fields remind us of the intricate and interconnected forces at work in the cosmos. They not only shape the galaxy's present but also hold clues to its future. And with that, our journey takes us to the next intriguing phenomenon, the ghostly tidal streams of stars that tell the story of NGC 4889, past collisions and cosmic encounters. Now, as we venture deeper into the cosmic tapestry of NGC 4889, we encounter the ghostly tidal streams, ethereal trails of stars that whisper tales of the galaxy's dramatic past. These streams are the remnants of ancient galactic collisions, where smaller galaxies were torn apart by the immense gravitational pull of NGC 4889. Imagine a cosmic dance where galaxies once merged, leaving behind these shimmering trails as a testament to their violent encounters. Tidal streams are formed when a smaller galaxy passes too close to a larger one, like NGC 4889. The gravitational forces stretch and pull the smaller galaxy apart, scattering its stars into long, flowing arcs. Over time, these stars settle into orbits around the larger galaxy, creating faint, ribbon-like structures that can stretch for thousands of light years. In NGC 4889, these streams are particularly striking, offering astronomers a unique window into the galaxy's history. What makes these tidal streams so significant is their ability to reveal the secrets of NGC 4889 past. By studying the motion and distribution of stars within these streams, scientists can piece together the timeline of galactic collisions that shape the galaxy we see today. For instance, the orientation and density of the streams can indicate the direction and intensity of past interactions, while the chemical composition of the stars can tell us about the origins of the galaxies that were consumed. One of the most fascinating aspects of these tidal streams is their longevity. Unlike other remnants of galactic collisions, such as dust clouds or gas, tidal streams can persist for billions of years. This makes them invaluable for understanding the long-term evolution of galaxies. In the case of NGC 4889, the presence of multiple tidal streams suggests a history rich with cosmic encounters, each leaving its mark on the galaxy's structure and composition. But studying these ghostly streams is no simple task. They are faint and diffuse, often blending into the background of the galaxy's brighter stars. To detect them, astronomers use advanced imaging techniques and computer simulations, which help isolate the streams from the surrounding stellar population. These tools allow scientists to map the streams in detail, revealing their intricate patterns and providing insights into the forces that shape them. As we reflect on these tidal streams, we are reminded of the dynamic and ever-changing nature of the universe. They are not just remnants of the past, but also clues to the future, hinting at how NGC 4889 might continue to evolve through further interactions with its cosmic neighbors. And with that, our exploration leads us to the next mystery, the rare carbon stars that add yet another layer of intrigue to this already fascinating galaxy. Now, shifting our gaze to another celestial marvel within NGC 4889, we encounter the rare carbon stars, stellar anomalies that stand out for their unique composition and striking appearance. These stars are unlike the typical stars we observe, as they are rich in carbon and other heavy elements, giving them a distinct reddish hue and a fascinating story to tell. Carbon stars are a rare breed, and their presence in NGC 4889 adds yet another layer of intrigue to this already enigmatic galaxy. So, what exactly makes a carbon star so special? These stars are in the late stages of their life cycle, having exhausted much of the hydrogen fuel in their cores. As they age, they begin to fuse helium into carbon, which then gets transported to their outer layers through a process called convection. Over time, this carbon accumulates on the star's surface, creating a thick atmosphere rich in carbon compounds. This abundance of carbon gives the star its characteristic deep red color, as the carbon molecules absorb blue light, leaving only the red wavelengths to reach our telescopes. But why are carbon stars so rare? Their rarity stems from the specific conditions required for their formation. Not all stars evolve into carbon stars, only those with the right mass and chemical composition can reach this stage. Typically, carbon stars are found in older stellar populations, such as those in NGC 4889, where stars have had billions of years to evolve. Additionally, the process of carbon enrichment is delicate and can be disrupted by external factors, such as interactions with other stars or the surrounding environment. This makes carbon stars a precious find for astronomers, offering a glimpse into the complex processes that govern stellar evolution. The life cycle of a carbon star is both fascinating and fleeting. After reaching the carbon-rich phase, these stars continue to shed their outer layers, creating beautiful planetary nebulae. Eventually, they exhaust their remaining fuel and end their lives as white dwarfs, leaving behind a legacy of carbon and other heavy elements that enrich the surrounding space. This material becomes the building blocks for new stars, planets, and even life itself, highlighting the profound impact these stars have on the cosmos. In NGC 4889, the presence of carbon stars provides valuable insights into the galaxy's history and evolution. By studying their distribution and properties, astronomers can piece together the timeline of star formation and the chemical enrichment of the galaxy. These stars serve as cosmic time capsules, preserving the conditions of the early universe and offering clues about the processes that shaped NGC 4889 into the colossal galaxy we see today. As we marvel at these rare carbon stars, we are reminded of the intricate and interconnected nature of the universe. Each star, no matter how small or fleeting, plays a role in the grand cosmic story. And with that, our journey through NGC 4889 continues, as we turn our attention to the peculiar binary systems that add yet another layer of complexity to this extraordinary galaxy. Now, as we venture further into the depths of NGC 4889, we encounter a phenomenon that adds yet another layer of complexity to this already fascinating galaxy, the peculiar binary star systems. These systems, composed of two stars orbiting a common center of mass, are not just a cosmic curiosity but a vital piece of the puzzle in understanding the dynamics of NGC 4889. Binary star systems are more common than you might think, but in NGC 4889, they take on unique characteristics that set them apart. Unlike solitary stars, binary systems interact in ways that can dramatically alter their evolution and behavior. For instance, the gravitational pull between the two stars can lead to phenomena such as mass transfer, where one star siphons material from its companion. This process can trigger dramatic events like stellar explosions or the formation of exotic objects such as neutron stars or black holes. One of the most intriguing aspects of binary systems in NGC 4889 is their role in shaping the galaxy's structure. The gravitational interactions between these pairs can influence the motion of nearby stars and even entire star clusters. Over time, these interactions can lead to the redistribution of mass within the galaxy, contributing to its overall stability and evolution. In some cases, binary systems can even act as cosmic lighthouses, emitting powerful bursts of energy that illuminate the surrounding space and provide valuable data for astronomers. But what makes the binary systems in NGC 4889 truly peculiar is their diversity. Some pairs consist of stars that are nearly identical in size and temperature, while others are mismatched, with one star being significantly larger or hotter than its companion. This diversity offers a unique opportunity to study a wide range of stellar phenomena, from the quiet, steady glow of stable pairs to the explosive drama of systems on the brink of collapse. Moreover, binary systems in NGC 4889 often serve as natural laboratories for testing theories of stellar evolution. By observing how these pairs interact and evolve, astronomers can gain insights into the processes that govern the life cycles of stars. For example, the study of binary systems has helped scientists understand how stars exchange material, how they end their lives, and how they contribute to the chemical enrichment of the galaxy. As we continue to explore NGC 4889, the peculiar binary systems remind us of the intricate dance of gravity and energy that shapes the cosmos. Each pair tells a story of partnership, interaction, and transformation, offering a glimpse into the dynamic processes that drive the evolution of galaxies. And with that, our journey through NGC 4889 takes us to the next mystery, the enigmatic fast radio bursts that occasionally light up the galaxy, leaving astronomers both puzzled and fascinated. Now, shifting our gaze to another cosmic enigma, we arrive at the mysterious fast radio bursts emanating from NGC 4889. These bursts are among the most puzzling phenomena in the universe, lasting just milliseconds but releasing as much energy as the Sun does in days. Detected sporadically and without warning, fast radio bursts have left astronomers scrambling to uncover their origins. One of the leading theories suggests that these bursts could be linked to highly magnetized neutron stars known as magnetars. These dense stellar remnants, born from the explosive deaths of massive stars, possess magnetic fields trillions of times stronger than Earth's. When these fields undergo sudden shifts or fractures, they might unleash the colossal energy observed in fast radio bursts. However, this is just one possibility, and the true source remains shrouded in mystery. Another intriguing hypothesis points to the collision of compact objects, such as neutron stars or black holes. These cataclysmic events could generate intense bursts of radio waves as the objects merge, sending ripples through space-time. Yet, despite the plausibility of this idea, no direct evidence has been found to confirm it as the primary cause of fast radio bursts in NGC 4889. What makes these bursts particularly challenging to study is their fleeting nature. Unlike other cosmic phenomena that can be observed over extended periods, fast radio bursts vanish almost as quickly as they appear. This leaves astronomers with only a brief window to capture and analyze them, often relying on luck and advanced detection systems to catch these elusive signals. Adding to the complexity is the fact that fast radio bursts often originate from vast distances, sometimes billions of light years away. As these signals travel through the cosmos, they interact with interstellar gas and dust, which can distort and scatter the waves. This makes it even harder to pinpoint their exact origins or decode the information they carry. Despite these challenges, the study of fast radio bursts holds immense potential. Each burst carries clues about the conditions of the universe it traversed, offering insights into the distribution of matter and the structure of cosmic environments. By unraveling the secrets of these bursts, scientists hope to shed light on some of the most extreme and energetic processes in the universe. As we ponder the mysteries of fast radio bursts, our journey through NGC 4889 takes us to yet another fascinating phenomenon: the powerful galactic winds that sweep through this colossal galaxy, shaping its evolution in ways we are only beginning to understand. Now, let's turn our attention to the powerful galactic winds that sweep through NGC 4889, shaping its structure and influencing its evolution. These winds are not the gentle breezes we experience on Earth, but colossal streams of gas and particles moving at incredible speeds, driven by some of the most energetic processes in the galaxy. At the heart of these winds lies the intense activity of star formation. In regions where new stars are born at a rapid pace, the energy released from young, massive stars can heat the surrounding gas to extreme temperatures. This superheated gas expands and is pushed outward, creating vast outflows that stretch across thousands of light years. These winds carry with them not only gas but also heavy elements forged in the cores of stars, dispersing them into the galaxy and beyond. But star formation isn't the only force behind these winds. The supermassive black hole at the center of NGC 4889 also plays a crucial role. As matter spirals into the black hole, it releases enormous amounts of energy in the form of radiation and jets of particles. This energy can heat the surrounding gas, driving it outward in powerful winds that can reach speeds of millions of miles per hour. These winds are so forceful that they can strip gas from nearby regions, halting star formation and reshaping the galaxy's structure over time. The interplay between star formation and black hole activity creates a dynamic feedback loop. While star formation drives winds that enrich the galaxy with new elements, the black hole's influence can suppress further star formation by clearing out the gas needed to create new stars. This delicate balance between creation and destruction is one of the key factors that shape the evolution of galaxies like NGC 4889. Studying these galactic winds provides astronomers with valuable insights into the life cycle of galaxies. By observing how these winds interact with their surroundings, scientists can better understand how galaxies grow, evolve, and eventually fade. Each gust of wind carries clues about the processes that drive them, offering a glimpse into the complex and interconnected forces at work in the cosmos. As we marvel at the power of these galactic winds, our exploration of NGC 4889 leads us to yet another intriguing phenomenon: the unusual infrared glow that emanates from this galaxy, hinting at hidden processes and structures waiting to be uncovered. Now, shifting our gaze to another fascinating feature of NGC 4889, we encounter the unusual infrared glow that radiates from this colossal galaxy. Unlike the visible light we see with our eyes, infrared light reveals a hidden layer of the cosmos, uncovering processes and structures that would otherwise remain invisible. This glow is not just a random phenomenon, it's a telltale sign of the galaxy's bustling activity and the intricate interplay of its components. One of the primary sources of this infrared glow is the vast clouds of cosmic dust scattered throughout NGC 4889. These dust clouds, composed of tiny particles of carbon, silicates, and other materials, absorb visible light from stars and re-emit it as infrared radiation. This process makes the dust clouds glow brightly in the infrared spectrum, painting a picture of the galaxy's hidden architecture. These clouds are not just passive observers, they play a crucial role in the birth of new stars, acting as the raw material from which stars and planetary systems form. But the dust clouds aren't the only contributors to this infrared glow. The galaxy's star-forming regions also play a significant role. In areas where new stars are being born at a rapid pace, the intense radiation from young, massive stars heats the surrounding dust and gas, causing them to emit infrared light. These regions are like cosmic nurseries, teeming with energy and activity, and their infrared glow provides astronomers with a window into the processes that drive star formation on a galactic scale. Interestingly, the infrared glow of NGC 4889 also offers clues about the galaxy's history and evolution. By studying the distribution and intensity of this glow, scientists can map out where star formation has been most active and how it has changed over time. This information helps piece together the story of how NGC 4889 has grown and transformed from its early days to the sprawling giant we observe today. As we delve deeper into the mysteries of this infrared glow, we're reminded that even the unseen aspects of the universe hold profound secrets. The light we cannot see with our eyes tells a story of creation, destruction, and the relentless forces that shape galaxies like NGC 4889. And as we continue our journey through this extraordinary galaxy, our next stop brings us to the rare and enigmatic neutron stars, whose extreme density and fascinating properties add yet another layer to the cosmic tapestry of NGC 4889. Now, as we venture further into the depths of NGC 4889, we encounter one of the most extreme and captivating objects in the universe, neutron stars. These stellar remnants are the collapsed cores of massive stars that have exhausted their nuclear fuel and exploded in spectacular supernova. What remains is a city-sized object with a mass greater than our Sun, packed into a sphere only about 12 miles across. To put it simply, a single teaspoon of neutron star material would weigh billions of tons on Earth. This mind-boggling density makes neutron stars some of the most fascinating objects in the cosmos. The formation of neutron stars is a dramatic process. When a massive star reaches the end of its life, it collapses under its own gravity, triggering a supernova explosion. The outer layers of the star are blasted into space while the core implodes, crushing protons and electrons together to form neutrons. The result is a neutron star, a celestial object so dense that it defies our everyday understanding of matter. In NGC 4889, these neutron stars are scattered throughout the galaxy, remnants of its violent and star-rich past. What makes neutron stars truly remarkable is their extreme properties. They spin at incredible speeds, some rotating hundreds of times per second, and possess magnetic fields trillions of times stronger than Earth. These characteristics make neutron stars natural laboratories for studying the laws of physics under conditions that cannot be replicated on Earth. For astronomers, they offer a unique window into the behavior of matter at its most extreme, from the nature of gravity to the limits of nuclear physics. In NGC 4889, neutron stars also play a role in the galaxy's dynamic environment. Some of these stars emit beams of radiation that sweep across space like cosmic lighthouses known as pulsars. Others may exist in binary systems where they pull material from a companion star, creating intense X-ray emissions. These interactions provide valuable insights into the life cycles of stars and the evolution of galaxies. As we explore the neutron stars of NGC 4889, we're reminded of the incredible diversity and complexity of the universe. These tiny yet mighty objects challenge our understanding of physics and inspire us to keep pushing the boundaries of what we know. And as we continue our journey, our next stop takes us to the cosmic ray accelerators, where high-energy particles race through the galaxy, revealing yet another layer of NGC 4889 cosmic drama. Now, shifting our gaze to another extraordinary phenomenon within NGC 4889, we encounter the cosmic ray accelerators. These powerful natural machines are responsible for producing some of the highest energy particles in the universe. Cosmic rays are not rays in the traditional sense, but rather high-speed atomic nuclei and electrons that travel through space at nearly the speed of light. In NGC 4889, these accelerators are thought to be powered by the galaxy's supermassive black hole and the remnants of supernova explosions, which act as cosmic particle slingshots. The process begins when particles are caught in the intense magnetic fields surrounding the black hole or the shockwaves from supernova. These fields act like giant cosmic catapults, accelerating particles to incredible speeds. As these particles race through the galaxy, they collide with other matter, creating cascades of secondary particles and radiation. This process not only generates the cosmic rays we detect, but also contributes to the galaxy's dynamic energy balance. The impact of cosmic ray accelerators on NGC 4889 is profound. These high-energy particles can influence star formation by heating up gas clouds, making it harder for them to collapse and form new stars. At the same time, they can also trigger chemical reactions in interstellar space, leading to the creation of complex molecules. This dual role makes cosmic rays a key player in shaping the galaxy's evolution and its interstellar environment. For astronomers studying cosmic ray accelerators in NGC 4889 provides a unique opportunity to understand the mechanisms behind these high-energy processes. By observing how these particles interact with the galaxy's magnetic fields and matter, scientists can gain insights into the fundamental forces that govern the universe. These findings not only deepen our understanding of NGC 4889, but also shed light on similar processes occurring in other galaxies across the cosmos. As we delve into the mysteries of cosmic ray accelerators, we're reminded of the intricate interplay of forces that shape the universe. These invisible yet powerful phenomena challenge our perception of space and inspire us to explore the unseen. And as we continue our journey, our next stop takes us to the theoretical dark stars, where the boundaries of our understanding are pushed even further, revealing yet another layer of NGC 4889 cosmic enigma. Now, as we venture deeper into the cosmic mysteries of NGC 4889, we arrive at one of the most intriguing theoretical concepts in modern astrophysics: dark stars. These hypothetical objects, unlike anything we've ever observed, challenge our understanding of the universe and push the boundaries of what we thought was possible. Dark stars are not stars in the traditional sense. They don't shine with the light of nuclear fusion. Instead, they are thought to be powered by the annihilation of dark matter particles, a process that could produce immense amounts of energy without the need for conventional stellar processes. The idea of dark stars stems from the presence of dark matter, the invisible substance that makes up a significant portion of the universe's mass. In the early universe, dark matter could have clumped together, forming dense cores that attracted hydrogen and helium gas. As this gas accumulated, the dark matter at the core would annihilate, releasing energy and preventing the gas from collapsing further. This unique mechanism could have given rise to dark stars, massive, glowing objects that emit light not from fusion but from dark matter interactions. One of the most fascinating aspects of dark stars is their potential size. Theoretical models suggest they could be hundreds or even thousands of times more massive than our Sun, making them some of the largest objects in the universe. Despite their immense size, they would appear dim compared to regular stars, as their energy output would be spread over a much larger surface area. This makes them incredibly difficult to detect, but not impossible. Astronomers believe that dark stars, if they exist, might emit faint infrared radiation due to their low surface temperatures. Advanced telescopes like the James Webb Space Telescope could potentially spot these elusive objects by searching for their unique infrared signatures. The existence of dark stars would have profound implications for our understanding of the universe. They could explain some of the anomalies in the early universe, such as the rapid formation of supermassive black holes. If dark stars were to collapse, they might directly form black holes, bypassing the usual stellar life cycle. This could provide a missing link in our understanding of how supermassive black holes, like the one at the center of NGC 4889, came to be. While dark stars remain purely theoretical for now, their potential discovery would revolutionize astrophysics. NGC 4889, with its rich and complex environment, could be the perfect place to search for these enigmatic objects. As we continue to explore this galaxy, the possibility of uncovering dark stars reminds us that the universe is full of surprises waiting to be revealed. And with that, we turn our attention to the final mystery of NGC 4889, the hidden secrets of its galactic core where even more cosmic wonders await. As we approach the heart of NGC 4889, we find ourselves standing at the edge of one of the greatest cosmic enigmas, the hidden secrets of its galactic core. This region, shrouded in mystery, holds clues to the galaxy's past, present, and future, and it's here that some of the most groundbreaking discoveries in astrophysics could be made. The core of NGC 4889 is a place of extremes home to the supermassive black hole we discussed earlier, but also a hub of activity that defies easy explanation. What lies within this dense, chaotic region, and what can it tell us about the universe as a whole? One of the most pressing questions about the galactic core is the nature of the materials swirling around the supermassive black hole. While we know that black holes consume matter, the exact processes at play in NGC 4889 core remain unclear. Observations suggest that vast amounts of gas and dust are being pulled into the black hole, but not all of it is being consumed. Some of this material is ejected in powerful jets, while other portions may form intricate structures like accretion disks or even new stars. Understanding these dynamics could shed light on how black holes grow and influence their surroundings. Another mystery lies in the strange signals emanating from the core. Astronomers have detected unusual patterns of radiation, including bursts of X-rays and gamma rays that don't align with current models of black hole behavior. These signals could hint at unknown physical processes or even the presence of exotic objects, such as intermediate mass black holes or dark matter interactions. Ongoing research using advanced telescopes and simulations aims to decode these signals, offering a glimpse into the hidden mechanisms at work. The core of NGC 4889 also holds clues to the galaxy's history. By studying the orbits of stars and gas clouds near the center, scientists can piece together how the galaxy has evolved over billions of years. Evidence suggests that NGC 4889 has undergone multiple collisions with smaller galaxies, each event leaving its mark on the core's structure. These interactions may have triggered periods of intense star formation or even altered the behavior of the supermassive black hole. Unraveling this history could provide insights into how galaxies like NGC 4889 grow and change over time. Looking to the future, the core of NGC 4889 promises to be a treasure trove of discoveries. Upcoming missions such as the James Webb Space Telescope and next-generation ground-based observatories will peer deeper into this region than ever before. These tools could reveal new details about the black hole's environment, uncover hidden objects, or even detect phenomena we haven't yet imagined. Every observation brings us closer to understanding the forces that shape galaxies and the universe itself. As we conclude our journey through the strange and wondrous objects of NGC 4889, the mysteries of its core remind us that the universe is far from fully understood. Each discovery raises new questions, and each question leads us deeper into the unknown. What will we find next in this incredible galaxy? Only time and the relentless curiosity of scientists will tell. Thank you for joining us on this exploration of NGC 4889. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more cosmic adventures. Until next time, keep looking up. From the supermassive black hole at its heart to the enigmatic star clusters and ghostly dark matter halo, NGC 4889 is a galaxy brimming with cosmic wonders. We've journeyed through 30 of its strangest objects, each one a testament to the galaxy's complexity and the mysteries that still elude us. Whether it's the ancient red giants, the mysterious blue stragglers, or the powerful radio jets, every object tells a story of the universe's grandeur and the forces that shape it. The warped spiral arms, hypervelocity stars, and remnants of galactic cannibalism remind us that NGC 4889 is not just a static collection of stars but a dynamic, ever-evolving system. And let's not forget the glowing nebulae, the elusive intermediate mass black holes, and the rare carbon stars, each one a piece of the puzzle that makes this galaxy so fascinating. As we wrap up this exploration, it's clear that NGC 4889 is more than just a distant galaxy. It's a window into the universe's past, present, and future. The discoveries we've made so far are just the beginning. With every new observation, we uncover more questions, pushing the boundaries of our understanding. Which of these 30 strange objects captivated you the most? Was it the supermassive black hole, the cosmic dust clouds, or perhaps the mysterious fast radio bursts? Let us know in the comments below. We'd love to hear your thoughts. If you enjoyed this journey through the wonders of NGC 4889, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss out on our cosmic adventures. The universe is full of mysteries waiting to be uncovered, and we can't wait to explore them with you. Until next time, keep your eyes on the stars and your curiosity alive. The cosmos is calling. What will we discover together?